Okay, since the last video I cleaned my pictures up a little bit, I just want to point out a couple things. So, for example, in this first problem, probability that z was less than -1, we found that to be 0.1587. But if you recall, the total area under the curve needs to be 1. And so whenever I was able to calculate the area to the right of -1, so this 0.8417. So, for example, the probability that z is bigger than -1 would just be 1 minus probability z less than -1, which would be 1 minus 0.1587, which would give me the 0.8417. So I just wanted to point that out because we can always, because we know the total area has to sum to 1, we can find all of the other areas. So I did that for all of our other examples. So we found the probability of all of these orange highlighted areas, but I just wanted to point out like we could find all of these non-highlighted areas by just taking advantage of that. Just the fact that the full area under the curve must be equal to 1. And so we can just do 1 minus the area um, of the orange area. So actually, it looks like I forgot to do that here. So 0.0028. So if I want the area of this unshaded part, this would be 1 minus 0.0228, and that would be equal to 0.9772. And this also just highlights some of like the symmetry ideas. You can see 0.0028 here and 0.0028 over here. And that's just because of symmetry. So the probability that z is less than -2 would be equal to the probability of z bigger than a +2. And that's just by the fact that the normal distribution is symmetric. So I just wanted to point that out. And hopefully, now that I've kind of cleaned these up, these make a little bit more sense because I know the last video, some of these sketches got a little rough. So anyway. Let's now move on to a different random variable. So let's say x is now normally distributed with a mean of 10 and a variance of 4. We want to say find some probabilities for x less than 14, between 8 and 12, and greater than 16. Okay, so if x is normal with a mean of 10, so I'm going to write mu is equal to 10. Variance, so sigma squared, is given to us as 4, which means that sigma, the standard deviation, would be the square root of 4, or just 2. Okay, so our tables only gave us probabilities with z values. So if we recall, our transformation to z is x minus mu over sigma. So using this formula, we can now calculate probabilities with x. So let's do an example. We have the probability that x is less than 14. So let's go ahead and use this formula right here to calculate this. So let's do that. So I want the probability x is less than 14. So I'm going to rewrite this as the probability that z, notice I'm moving from x to z, is less than, and now I just go ahead and use our formula. So x minus mu, so my x here is 14, so I'm going to say 14 minus our mean, 10, divide by our standard deviation of 2. So now if I simplify that, I have the probability that z is less than, so 14 minus 10 is 4 divided by 2, whoops, would be a positive 2. Okay, so the probability that z is less than 2, well, we already found that in our prior example, so let's go ahead and look that up. So we found the probability here, right here, the probability that z is less than 2 to be 0.9772. So let me go ahead and use that. So 0.9 equals 0.9772. Okay, now we can do these for the next two examples. If you feel comfortable to go ahead and pause the video and practice, but or if you want to watch one more example and then pause it and try to do the last one on your own, that's fine as well. So let's do this next one. So we have the probability x is between 8 and 12. So I need to transform this into z. So I'm going to say x is 8 minus mu is 10, divide by our standard deviation of 2. Right, all I'm doing is I'm plugging in to this formula here. We want to convert x to z. How do we do that? We take our x value. X here is 8. Subtract mu. Our mu is 10. And divide by our standard deviation, which is 2. And I'm just plugging that in. So x, 8, minus mu, 10, divided by sigma, 2. And that's how we get this formula. Okay, but we want to do that for both 8 and 12. So again, I'm moving from x to z. So now it's 12 minus 10 divided by 2. Now I can simplify this to the probability. So this is going to be negative 1 less than z less than 1. Okay, so the probability x is between 8 and 12 is the same as saying the probability z is between negative 1 and 1. But again, we already looked this up or calculated this. So let's go back up. So the probability that z is between negative 1 and 1, we did it right here, is 0.826. So 0.6826. Okay, one more. Again, I would recommend trying this on your own before seeing me do it, but okay, here we go. We have the probability. Again, I'm going to switch this from x to z is greater than, so my x now is 16. Mean hasn't changed. It's still 10, just like in the other examples, as is the standard deviation of 2. That remains unchanged. So that's going to be the same as the probability that z is bigger than 3. So let's go ahead and see what that is. Okay, so we technically didn't do this one. We did z less than 3. We found that to be 0.99865, but notice that we already have it. It's 0.00135, right? Because it's just 1 minus the highlighted area. So this was 1 minus 0.99865 is equal to 0.00135. Or we could have used the idea of symmetry of the normal distribution, where we know that the probability that z less than negative 3 would be equal to the probability that z is bigger than positive 3, which is 0.00135. So that means our answer is 0.00135.